According to Guyton and Hall, pulmonary ventilation is the inflow and outflow of air between the atmosphere and the lung alveoli. This movement of air is the major factor that dictates respiration, more specifically, external respiration. The diaphragm and the muscles of the rib cage are the main muscle groups of ventilation. During inhalation, the diaphragm contracts and the rib cage moves upward, providing more space for the lungs to expand to let in more air. When we exhale, these muscles relax to expel out air in what appears to look like a recoil of sorts. Of course, when talking about respiration, muscles are not the only thing affecting gas exchange. We also need to take into account the pressure in the lungs. When air pressure in the atmosphere is less than the air pressure in the lungs, we tend to expel more air than what we would normally do. The opposite is also true to achieve the opposite effect. To decrease the pressure inside the lungs to make it less than the pressure in the atmosphere, we need to increase its size. We call this effect Boyle's law. The rule goes that a more concentrated space of molecules would result in more pressure. But if we increase the size of the space, despite the same number of molecules in lungs, we would be able to decrease the internal lung pressure. This is a rule of diffusion and can be applied to more than just our cells and lungs. This can also be applied to our alveoli. Despite the alveoli's thin epithelial wall, it still needs to build enough pressure to expel oxygen toward the oxygenated blood. There also needs to be low enough pressure in the blood so that oxygen can easily pass through the alveoli's endothelium and enter our bloodstream. Speaking of the alveoli's endothelium, let us talk about that. The alveoli's walls are made up of thin, simple squamous cells that can easily be penetrated by oxygen and carbon dioxide. While this is thickened and overinflated by a disease like pulmonary emphysema, it is harder for oxygen to participate in any gaseous exchange despite a buildup in pressure. This is also not taking into account that we expel more CO2 than we would take O2 due to how soluble carbon dioxide is to our respiratory fluids. If we suffer from pulmonary edema, there is a chance you may suffer first due to a lack of oxygen first, then in the overabundance of carbon dioxide in our body. While there isn't a solution to our normal intake of oxygen, the best we can do is maintain the structure of our alveolar walls by not inhaling any harmful gases. That way, normal respiration can be achieved without any trouble in our part.